module. And so, of course, here we're referring specifically to kind of waste that's generated by humans, all the materials that we discard, including, trash, sewage, sludge, agricultural waste, the kind of uniquely human concept here. And, this waste and these materials have a really profound effect on the environment. And unless reused or recycled, the waste that we'll be talking about today accumulates. And much of this can be toxic to other living organisms and, requires a sustainable management plan. The case study in your textbook is focusing on kind of the phenomenon of microplastics and plastic pollution in general. And these microplastics, such as the little blue beads that you can find here, are really common in personal care products and are just one example of how human waste products are causing a lot of issues. So this particular case study focuses on the Great Lakes region and highlights research done by a chemist who was actually aboard a research sailboat named the US Niagara. And she was participating in the world's first survey of plastic pollution in Lake Superior. And they were finding, styrofoam and other types of waste mixed in among kind of seaweed and algae. And then found kind of the first piece of plastic, in their survey of the waste on Lake Superior. And on that survey, they found, a variety of different large plastic pieces, like a wrapper from a cigarette box, parts of a bottle cap. But they were particularly shocked when they returned to the lab and looked at some of their samples under a microscope. What she found when looking under the microscope is that the water was filled with plastic particles that were too small to be seen by the naked eye. And she estimated that just in Lake Superior, that its waters harbored something like 30,000 plastic particles per square kilometer. And since that time, she's done more surveys and collected more samples from this region and has found an even greater concentration of these plastic particles. So this is what we're referring to as microplastics. And of course, they float in the Great Lakes, but in all of our bodies of water at this point. And most of them are, less than a millimeter in size. Again, can't be seen by the naked eye, but it doesn't mean that they're harmless. These are embedded in a variety of different chemicals, flame retardants, dyes, and they're likely accumulating in such large concentrations because they leak out from the plastics in the surrounding water. And they kind of act like a poison pill in that respect. So microplastics can absorb toxic substances from the water, but they're so incredibly tiny that they're really easily ingested by organisms, especially those at the base of the food chain, things like phytoplankton. And so again, this work is ongoing in this particular region, but is also continuing in other parts of the world. And we've found, since this time that microplastics are essentially everywhere. They're in soil, they're in our oceans, our waterways, they're even in air. There's been more awareness around particular products, the microbeads that I mentioned before coming from things like facial scrubs and toothpaste, tiny fibers from polyester clothing. And it shouldn't come as too much of a surprise, just knowing how much plastic we produce, something like 380 tons of plastic each year. So it's not surprising that there's tiny plastic fragments that are now kind of scattered around the planet, covering our surfaces. So part of what we want to consider is, how those materials are affecting the environment, how they're affecting marine and land organisms, and if if and how they are affecting human health. So once again, we're talking here specifically about human waste and solid waste more specifically. So any of the many materials that we discard. In natural ecosystems, there is no such thing as waste because everything is connected and circular. So in a natural ecosystem, one organism's waste is another organism's food source, right? Everything gets converted and broken down and recycled. Forms of matter that are generally dangerous to living things tend to stay buried deep underground, right? They're only released during very kind of extreme events like a volcanic eruption. So the reason we're focusing on the human part here is that human ecosystems are another story. We're not handling matter in a circular way, the way natural ecosystems do. We are handling matter in a linear way, right? We extract matter, transform it, use it, and then it's discarded. Often in ways that make it hard for us to reuse or hard for nature to reuse, nature to reclaim. We spoke early on about the law of conservation of matter, right? So there's basic biological and physics principles at work here, right? And we know that matter can't be created or destroyed, it only changes form. So here's a diagram here of the kind of ideas that I just articulated, right? So we make a lot of trash, but we as humans follow this linear system, unlike other species, in terms of how we discard it and the types we generate, again, make it harder and impossible to reuse. So we tend to follow the kind of take, make, use, discard linear system. Whereas natural ecosystems naturally participate in a circular system where every step along the way, there's a reuse, recycle, and return. And so that can form or serve as a source of inspiration for kind of modeling human interactions with waste around these circular or natural ecosystems. So we're going to look specifically at municipal solid waste and kind of the types and proportion of municipal solid wastes in the municipal solid waste stream in the United States. And as we'll kind of focus on moving forward, not all waste is created equal, right? Waste that can be broken down by chemical or physical processes is considered degradable, right? So we refer to kind of biodegradable waste. But there are a whole lot of waste items that we produce as humans that are non-degradable, right? Incapable of being broken down under normal conditions. So we want to differentiate between those two different types of waste. And of course, they're going to require different types of management. So municipal solid waste is the everyday garbage or trash that are produced by individuals or by small businesses. So almost any human activity you can think of is generating some form of waste. Any kind of process that produces food or consumer goods, any kind of construction, road building, agriculture, all of that generates waste. We just finished talking about energy extraction, right? Harvesting coal, harvesting minerals, all of that generates waste and contributes to pollution. But this municipal solid waste is done on those large scales and also on, again, these everyday small scales of individuals or, again, small businesses. And in fact, kind of urban dwellers produce most of the world's municipal trash, something like 2 billion tons of solid waste each year. And that amount is predicted to double in the next 5 or so years. the per capita rate of trash generation is kind of positively correlated with income level of a country. So kind of the wealthier a country is, the more waste is produced. Plastic is an exception to that, as I've noted here. Kind of interestingly, plastic trash is one type of waste that's not closely tied to income. So its production rates in countries around the world are kind of about the same, regardless of income. Americans create the most garbage, more garbage per person than just about any other country in the world. So these numbers are from 2015. But at that time, each American produced an average of about 4.5 pounds of solid waste per day. That's up from about 2.5 pounds in the 1960s. So when you multiply that by, more than 300 million people living in the United States, it's a lot of trash, something like 260 tons per year, which is twice the amount of other countries, twice the amount of Japan, Belgium, Norway, and it's about 10 times the amount produced by less developed countries. And here's a graph summarizing what I just said. So again, generation rates of municipal solid waste from the 1960s to 2015, and we're looking at total versus kind of per capita waste generation. And so once again, we're referring here to trash produced by homes and businesses, and kind of the volume of industrial and agricultural waste kind of far exceeds the amount of municipal solid waste. We still are producing millions of it. So the red here, again, is referring to pounds per person per day. And we see how that has gone up over the years. And then the left-hand axis here is referring to the total generation in millions of tons. And here's a summary of what that looks like kind of before recycling. So the vast majority of the garbage we're referring to here comes from, a pretty familiar variety of goods, things like paper, wood, rubber, glass, textiles, and of course, plastic. Plastic's cheap. It's become a staple of, again, all countries. It's light enough to float. It's durable enough to persist for hundreds of years, even floating across kind of thousands of miles of ocean. So what we're looking at in this diagram here is the total municipal solid waste generation kind of before recycling, and just, again, the proportion attributed to food waste versus paper versus plastics, green waste, so on and so forth. And again, I'm kind of pointing out here that this is referring to kind of pre-cycling rates. So some questions to start to think about is, which of these categories are naturally degradable, like green waste and yard trimmings, for example. What percent of the whole each of these make up? As I just mentioned, plastics are, particularly problematic in terms of their lifespan, and it's a big piece of the pie here. Which of these can be recycled, and how do we manage these different forms of municipal solid waste in different ways? So I don't think it's any news to you to consider some of the impacts of solid waste management. So in cities in the United States, municipal solid waste makes its way from our garbage cans in our homes and small businesses to garbage trucks, and finally to some kind of waste facility, right? And there are different versions of that. We'll talk about a little bit of that. But that's not how it works all over the world, right? A good half of the world's populations, think of 4 billion people, don't have access to waste management in the way that we do in the United States. So there's no municipal dumpsters, garbage isn't picked up and hauled off. So it gets tossed where they can. And in some cases, those are in, on the side of the road. Those could be just piles on the ground, or next to rivers or on coasts, or next to bodies of water. And the impact that this has on the environment, of course, is varied and serious, and has impacts on wildlife, as well as the health and safety of humans, right? So there's a few examples of the negative impacts here, including trash attracting insects and rats and other organisms into higher proportion in communities where humans are living, and they could be involved in the transmission of disease. We'll talk a bit more about plastic in oceans, but plastic in ocean ecosystems cause significant harm to wildlife that ingest plastic waste or get entangled in them, or are exposed to toxic chemicals that are again released by the plastics. And there's a variety of sources of pollution. Improperly handled or stored trash can contaminate soil, can wash off and be carried off by rains, can contaminate water sources. And again, the pollution part of this, we've talked about previously. So I spoke ahead a little bit, but to make the point of those negative impacts in the previous slide, just to emphasize again that, in the United States, we certainly have our own flaws in how waste is managed and transported and processed. But again, keeping in mind that in many countries across the world, there's no formal waste disposal system, and trash is often ending up, on the streets, near bodies of water, and increasingly so in our oceans. There's been a lot of documentation in recent years of seabirds and other marine wildlife ingesting plastics, mistaking them for food. At this point, it's rare to find a dead seabird that does not have plastic in their digestive tract, which is just really kind of horrifying to think about. So I mentioned a lot of that trash gets dumped near bodies of water. And so improperly discarded trash has accumulated in record amounts in bodies of water, and specifically in the ocean. And our oceans now, especially plastic debris, have collected in what's known as garbage patches, which is crazy that we even have a term for that, and that this is such a prominent feature now of our oceans. The image that you're seeing here is illustrating the 5 major gyres in the world's oceans, and these reflect the patterns of ocean circulation. More specifically, these are kind of ocean currents or regions of the ocean where strong currents kind of encircle regions with weaker currents. So here we have, our California current flows from north to south along its coast, right? And this is what's bringing kind of cool water from the north down along our coast, right? And these are influenced by convection circles and wind patterns across the globe. So it's difficult once trash finds its way into one of these gyres. It becomes part of this movement of water, making it difficult for waste to drift out of the circle once it's been encircled. It's estimated that there's well over 100,000 plastic pieces per square kilometer in the North Atlantic Gyre. And again, it's just in recent years that some really startling photos have started to surface, documenting these garbage patches. Our local one here is referred to as the Great Pacific Garbage Patch, and it's a collection of marine debris in the North Pacific Ocean, and it's referred to as the Pacific Trash Vortex as well. So it spans waters from the west coast of North America all the way to Japan. Again, it's carrying a significant amount of marine debris and trash in these very important waters off of our coast. There's been expeditions kind of traveling through these garbage patches to study their composition and to try to raise awareness. It was first discovered, the Great Pacific Garbage Patch was first discovered in 1997. There was a more recent expedition in about 2015 where aerial drones were used to kind of assess the extent of the trash, and that survey determined that there's 100 times more plastic by weight than had previously been measured. And they discovered more like permanent plastic features, essentially plastic islands that are over 50 feet in length. So certainly, you know, we can agree that limiting or eliminating our use of disposable plastics and kind of increasing our use of biodegradable resources will be a way to reduce the impact of the Great Pacific Garbage Patch, but those materials are not going away anytime soon. And so we will be living with the consequences of this plastic in our environment for a very long time to come, okay? And again, that is because plastic doesn't break down. It doesn't biodegrade through any sort of natural means. So this is an example of what that water looks like in these garbage patches. So this is a bucket holding, like, you know, the tiny bits of visible plastics, including a whole lot that you cannot see with the naked eye. So, you know, sunlight, wind, wave action can break plastic into smaller and smaller pieces, converting it to, again, microplastics, but we don't get rid of the materials altogether. And again, these plastics just continue floating along. Your textbook has one particularly dismal estimation that is according to a report from the MacArthur Foundation that predicts, based on the size of these garbage patches, that the amount of trash entering the ocean will double by 2030 and quadruple by 2050. And if that prediction is correct, our oceans would contain more plastic by weight than fish by 2050, which is just a mind-blowing thing to wrap your head around. So how do we prevent waste from washing off into our oceans and bodies of water? So we're going to talk a little bit about disposal methods. And again, as I go through this, keep in mind that this is a discussion that's focused primarily on the United States, but a large population around the globe does not have any version of kind of these disposal methods. But we will consider what we do here in the United States. Proper solid waste management is an important part of keeping plastic, keeping trash, again, out of oceans, lakes, and rivers, out of forests, out of grasslands. So we'll compare kind of open dumps and sanitary landfills in terms of their kind of trade-offs, pros and cons. And this is regulated by the federal government. So all solid waste in the United States is regulated by the 1976 Resource Conservation and Recovery Act. So this is a federal law that regulates the management of solid and hazardous waste. And it's administered by the Environmental Protection Agency. So the EPA is tasked with providing the rules and regulations to administer the law, and then states are in charge of implementing it kind of within their jurisdiction. So it's actually through the Resource Conservation and Recovery Act that the United States has banned the use of open dumps for waste disposal. And I need to actually look up what year these were banned, because certainly it's something, I'm looking it up right now, but certainly this is something that was a feature of my childhood. So it looks like the law was enacted in the late 70s, but they were not closed right away. So these open dumps continued into the 1980s. And I just remember one near my house, and I remember always rolling up the windows when we would drive by the dump, because it was just an open dump and it smelled terrible. So this is kind of the cheapest way to get rid of human trash, and involves just, of course, dumping trash in waste piles. The United States is not alone in having banned this version of waste management. So a lot of other countries have, but once again, in sort of lower economic countries or less developed countries, this is still a very common way to deal with waste. There's all sorts of obvious disadvantages that come with this. I already mentioned the smell. Open dumps attract, flies and rats, other kind of like human health hazards. The materials leak into the soil and can wash out into nearby bodies of water. Leachate is the term that we use to refer to that contaminated water. So water that carries dissolved substances that can percolate through the soil. So we no longer manage waste in this way, but a lot of regions still do. What's become more common is what are referred to as sanitary landfills. So these are disposal sites that seal in trash at the top and the bottom. So that prevents its release into the atmosphere, but the sites are also lined and contained so that it prevents leaching from the bottom. And, the trash is managed, it's kind of dumped in, but also covered with soil daily. So there's protective layers of gravel and soil, thick plastic, like you can see here. And the covering of the trash on a daily basis helps to kind of reduce those unpleasant odors that I described, and helps to reduce things like rats and other animals being attracted to the dump. So it improves upon some of the issues of that are associated with open dumps, but there are still a variety of downsides. The compacting of trash kind of under layers of soil tends to exclude oxygen and water, so that kind of aerobic bacteria, the ones that are needed to help with the decomposition, can't survive. Things like newspaper that would degrade in a matter of weeks if it was in kind of aerated soil that supported those aerobic bacteria can be in a landfill for decades. Again, just because those bacteria are not able to do their job. There are other bacteria that can live in those oxygen poor environments. Those are anaerobic bacteria, and they play a role in decomposition, but they are much slower, which is why something like newspaper would take longer to break down. And by the nature of them being anaerobic, they produce a lot of methane in the process. And we know that is a greenhouse gas that contributes to climate change. And landfills also take up a really large amount of space. So in communities where land is at a premium, it's hard to find land to develop a landfill, right? And this is kind of a NIMBY problem, not in my backyard problem, right? Nobody wants to live next to the landfill or across from the landfill. And there's often, it's a type of project that often brings out some like really strong and vocal opposition from local people. We talked about this earlier with other issues, but I mentioned it with nuclear sites, and we talked about it with pollution and mining, but since so few people want disposal sites in their communities, they're often concentrated in kind of minority or poorer communities where perhaps there's fewer resources to object, provide the strong and vocal opposition that keeps it out of wealthier areas. So that is an environmental justice issue, which is, again, something we'll talk about before we wrap up this module. So like everything else we've talked about this semester, each of these different methods comes with its own trade-offs. The EPA has kind of a hierarchy of preferred disposal methods for municipal solid waste. And at the top of that list is source reduction, right? Preventing materials from ever entering the waste stream. And that's a really important thing to emphasize, followed by recycling, composting, right? Landfills are the last choice, but we're not meeting those goals. Like landfills still handle the greatest percentage of most of our waste. And this varies regionally, but is generally true. Okay, let's briefly look at some of the other methods of waste incineration. So this is kind of at the bottom of the EPA's list of disposal methods, and this is incineration or burning trash at high temperatures. And we do this with a lot of garbage, so thousands of tons per day wind up in these specially designed incinerators. So again, these facilities that specialize in burning trash at these super high temperatures. In the US, we do this with about 12 or 13% of our trash. Europe incinerates a much higher proportion, about 42%. This method reduces the volume of trash dramatically, by about 80 to 90%. And there's another benefit, which is that, the garbage can be converted into usable energy. So the heat that's produced during incineration can be converted into steam energy or used to produce electricity. And so for that reason, the EPA considers incineration with energy capture as a better disposal option than landfilling or incineration without energy capture. So that's kind of the caveat there. So there are some significant advantages, but once again, these are often met with the not in my backyard NIMBY protests as well. Burning waste contains plastics and other chemicals, right? That releases toxic substances into the air. It pollutes air and water. It produces toxic ash. So, once again, most communities don't want to live near that or be exposed to that. They're also extraordinarily expensive to build. That is an upfront problem in developing these and keeping them running efficiently. Sorry, I spoke ahead, but those are the cons that I just mentioned. And of course, no matter which of those methods we use, screen has frozen here. Let me reshare this. No matter which of those methods we use, we always have kind of the added challenge of dealing with particular hazardous waste. So whether we're talking about incineration or landfills, there are certain materials that just cannot be properly disposed of or dealt with in that way. So I just want to take a moment to briefly look over the kind of common household hazardous waste and how individuals deal with those, because these are generally things that should not end up in landfills or incinerators for reasons associated with health risks and environmental contamination. So hazardous waste is referring to waste that's toxic, flammable, corrosive, or radioactive. And most modern households contain these types of chemicals and products. These could be certain household cleaners, automotive supplies, paints, fluorescent light bulbs, batteries. These are all things that are classified as hazardous and shouldn't be disposed of with regular trash. But unfortunately, not everyone knows how to properly dispose of those hazardous wastes, or even kind of which items are hazardous. So lots of half full cans of paints, dead batteries, things like that end up in landfills where that they can be sources of environmental contamination. And so this is something where there is some responsibility that lies with local consumers. We all live in different areas here, but local communities have different methods for safely disposing. And often at the county level, the county will sponsor events, specific events throughout the throughout the year, where you can drop off hazardous waste or e-waste. So that information, looking at the waste department for your city or county is a good place to start. We talked a bit about e-waste when we talked about mining, so I don't want to be repetitive here, but I'll just emphasize again, from the waste perspective, discarded electronic devices, computers, televisions, cell phones, anything that contains a circuit board is a really important thing to dispose of properly, in part, of course, because of the waste, but also because of the mining issue that we talked about previously, right? Computers, cell phones, televisions, they contain precious elements, and reclaiming those materials can reduce our need to mine for them, to extract them, which is a huge environmental issue. So that's important. And again, different cities and counties have programs related to that, where e-waste can be safely recycled or collected. So this is just a few examples of household hazardous waste from your textbook, including things that are, again, toxic, flammable, or corrosive, like acids. And lots of these chemicals that kind of enter our homes are quite dangerous and should not be discarded in the regular trash. And again, the recommendation is to always be informed with how your local waste management deals with these types of items. There's another good website you can visit called earth911.com that has information on disposal of these types of products. We have a discussion thread associated with this module where you can get into a bit more detail about some of your local approaches to waste management and recycling. And composting is one option for reducing the amount of solid waste we send to the landfills. In fact, in the city that I'm in, our waste management company collects our compost and green waste, and it is converted into biofuel. So there are some really creative ways for dealing with compost, but we can do this on small scales or on large scales. It's a method that is mimicking nature, right? It's allowing waste to decompose quickly and then using that product to either, again, produce biofuel or return nutrients to the soil. And this can be done on small scales, right? Just a compost pile in your backyard, in your home, in schools, and small offices, or like in the example that I mentioned, in kind of larger municipal digesters. This composts involve the use of kitchen waste, kitchen scraps, but also other organic waste, things like paper, yard debris. And in a properly managed compost, meaning you have a balance of what's referred to as browns and greens. Browns are things that are higher in carbon. Greens are things that are higher in nitrogen. And a healthy compost requires a proper balance of those types of materials, as well as water and aeration. And the way that you generally ensure that there's enough air for microbes to do their thing, is to regularly turn or stir the pile to increase aeration. Depending on the temperature that you're maintaining a compost in, you can convert kitchen waste into a soil-like product in a matter of just weeks or months. There's all sorts of techniques that would increase the rate of that conversion process. And as I mentioned, this is done on a municipal or on an industrial scale as well. And this can be both creating compost on a much larger scale, or other ways of using green waste. Okay, but this is one way to reduce the amount of material going into landfills or incinerators, but we have to just deal with the problem before it starts. So any kind of good environmentalist will tell you really what this all comes down to in terms of waste management is the 4 R's: refuse, reduce, reuse, recycle. They used to be 3 R's. Oops, sorry, my screen is freezing again. Give me one moment here. Okay, we're back, but the 4 R's. All of this is to focus on a phrase that I used earlier, which is what we'd call source reduction. So reducing the generation of waste as kind of the number one choice method for addressing solid waste problems. So, use less stuff so there is less waste to begin with. And I guess I'll say one more thing, but I'll leave that there. So how do we do that? The first step is, again, to refuse. Don't consume things that we don't need to. We live in such a consumerist society and culture. Being more savvy and more thoughtful about what you need and what you don't need, and especially refusing those particular items that are harmful to the environment. When we save a resource by refusing to use it, that resource lasts longer, which in turn means that less pollution will be generated, disposing of it and producing replacements, and more will be available for the future. So it doesn't mean like never using a particular resource. It means using resources, using items at a more sustainable rate. Okay. So, there's been a cultural shift with respect to like plastic bags and plastic straws. And so being more cognizant of choices like, carrying a metal straw with you and refusing a plastic straw, carrying a water bottle with you instead of consuming small plastic water bottles, right? And this is not to say that you'll never drink out of a water bottle again or never use a straw again, but like on average, reduce the amount of times that you are refusing to use those products. For certain commodities or items that you can't completely refuse, then we work on reducing our consumption of it or minimizing our overall ecological footprint by making very careful purchases. This, relates to clothing items, right? Investing in materials that are going to last you for a longer period of time, choosing kind of durable, repairable goods. A lot of this can relate to packaging. I brought up the kind of plastic bottle issue. If you do find you have to purchase a bottle of water, like buy a larger one instead of using several smaller bottles, right? So it's not maybe the best choice with respect to like you're still consuming plastic, but it's the lesser of two evils. And all consumers can really greatly reduce the amount of waste they generate by paying attention to packaging, right? That accounts for a huge proportion of US trash, and that has increased significantly with the increase in the commonness of online shopping and online shifting. If you can't avoid using a product, the next best choice, the third R, is reuse. So again, something consumers can do with with very little effort is by, choosing versatile and durable products over disposal ones. Products that are produced for limited use are basically just made to be trash. So avoiding those types of products, they're pulling resources out of the environment, and they produce pollution at every step, right? Production, shipping, disposable. So think about things like disposable razors, right? Like plastic plates. What was this meant for? Is it meant for just a one-time use? How long will it last? Like, what other purposes might it be used for, right? And trying to focus on those items that can be used for multiple purposes and can be reused. Recycling is now, really on this list of ours, this is kind of written in order, right? So recycling is sort of the last in this chain of options, right? So you should first try to refuse, then try to reduce, then try to reuse. And then if we've given all of that, if we've done that as much as possible, kind of the final R that we're left with is recycling, which of course is the process of converting waste into new products. And recycling certainly reduces the amount of trash that ends up in the landfill, but it does more than that. It reclaims raw materials, like we mentioned for e-waste, and that then limits the amount of raw materials that have to be harvested or mined. And in most cases, this helps us conserve limited resources, trees, precious metals. I talked about how successful the recycling process is for aluminum, how much aluminum we're able to recover. We need to use that as a source of inspiration for doing a more efficient and a better job of recycling other materials as well. Kind of what to recycle has always been a process. There's a few examples here of what I just walked through. I'll let you kind of look through those examples from your book. But certainly there's an education element to knowing what to recycle and how. And so there is better education that's needed to know, how to prepare for recycling, how to sort recyclables properly, what needs to go to a drop-off center, what gets collected by your city. And that is different from city to city. And that's sometimes confusing for people as well. But taken all together, we collectively need to be accountable for the waste we produce and the really profound effects it has on the environment. And sustainability very much requires that we make an effort to generate less trash, in addition to improving our waste disposal methods, locally in this country and globally as well, to follow a more circular production path. And I mentioned this like startling fact earlier with respect to the ocean garbage patches, but I think we can all agree that this is a fate for our oceans that we absolutely want to avoid.